Yes, class. Am I audible to all of you?
Yes, ma'am.
Jobita, Hashid, Zainab,
Yes, ma'am.
Shaima. All right. So again, your timings have been changed. Okay, now I think we'll be having the classes on Saturday and Sundays again. Now, see, we had actually started with the conversion of one formula to another. That means one system of units into another system of units. So basically, like Newton, Newton was amongst the SI unit. So we could convert it into CGS unit, right? Yes. So let us continue and let us complete this portion because only this much amount of portion is left from your dimension analysis. So we'll be able to start the new topic also. So yes, what did we discuss? How to convert one unit into another? Newton into dyne, suppose it was given. So even if it was Newton into dyne, you have one basic formula that you have to apply. Means N1 U1 is equal to N2 U2. This is all that you have to apply. Means N1 is the number of the first unit. Second, U1 is the unit 1. Then N2 is again the number of the second unit. Number means the magnitude. And U2 is again the unit of second. So N1 U1 is equal to N2 U2. You have to apply this. Then whatever is missing, if it's N1, if it's N2, that you have to find out. How to find out? We divide both the terms, right? Simple cross multiplication we perform. So for N2, suppose N2 is missing. So we bring it in the denominator. Then we write their actual units which are given in the question. Once we have the actual units with the powers and the dimensions that we have put, then we actually substitute the one unit into another unit. All right. So 1 kg by 1 gram was given. So 1000 gram by 1 gram was kept like this, or 1 meter by 1 centimeter. So 100 centimeters by 1 centimeter, like this we'll convert. If it's given in hours, then we'll convert it into seconds. If it's given in minutes, then again we'll convert it into seconds like this. Because we want to cancel all the units so that we have the final number given. This you can learn also. 1 Newton is equal to 10 to the power 5 times. You had written this question. Anybody who got the answer? 10 joules into Earth. Hashid, you have got?
No, ma'am.
You are not audible. Just type it in the chat column. Okay, let me discuss it then. See, again we have to use N1 U1 is equal to N2 into U2. All right. Now what is N1? N1 is 10. U1 is joules. N2 is missing. U2 is erg. All right. N1 U1 is equal to N2 U2. Now 10 into the units of energy. Why? Because joules is the SI unit of energy. So for energy, I have told you it is always ml square T to the power minus 2. For any type of energy, any type of work done, you have this dimension. All right. So for the first system of unit, this is what we have. N2 is missing. U2. The dimension will be same because both are referring to energy only. But this time these will become 2. M2, L2, T2. All right. Then when we are talking about N2, we have to find out N2. So what we'll do? 10 into this term will be there. That is M1 will be there, L1 will be there, T1 will be there. But this term, that is all these M, L and T will come in the denominator. This becomes M2, this becomes L2, this becomes T2. And what are their powers? This is M is 1, L is square, and T is to the power minus 2. This time we do not have 1, we have 10, right? In the previous question, 1 Newton that was only 1 Newton. That's why we were excluding it. Right now it is given properly as 10. Now we just have to convert one system of unit into another. So what N2 will be equal to? 10 will be their mass in the SI system. It's 1 kg by 1 gram to the power 1. Again, 1 meter by 1 centimeter to the power 2. And 1 seconds by 1 seconds to the power minus 2. Again, seconds bracket will be cancelled. So see, N2 will be 10 into 1 kg is 1000 gram by 1 gram to the power 1. 100 centimeter by 1 centimeter to the power. All right. So gram will be cancelled. Centimeter will be cancelled. Seconds were already cancelled. So I'm not writing it again. What is left? 10 into. This is 10 to the power 3. This is 100 into 100 because square is there. This becomes 10 to the power 4. So we have 10 to the power 8. So N2 will be 10 to the power 8. Means 1 joule is equal to 10 to the power 7 erg. So 10 joules will be equal to 10 to the power 8 erg. This was our question. And this is what you can remember. No need to remember 10 joules. Remember it for 1 joule. You'll be able to calculate for any other value that is. Fine. This is how to convert. It's a revision also. So write it down. Now another question we'll see. But these were the basics questions only. How we have to convert. Write it. One more question we'll see. Duration is 1.5 hours. See, class, then for the duration, keep your 2 hours with you, 6:30 to 8:30. IST, just convert the time for your places. So 2 hours, please keep it for the class. 1.5 hours will be the class that will be going on, and half an hour you all will get for your after class assessment. So on the days when we will not be having the after class assessment, if the topic is not completed or if the particular topic does not need any after class assessment, so we will be continuing with the class. So that's why keep your 2 hours for the class. All right. 2 hours on Saturday and then 2 hours on Sunday. All right. Let's come to this question. This says that convert power of 60 joules per minute into a system in which mass is 100 grams, length is in 10 millimeters, and time is in minute. See, it's a little tough question, but method is same. The way you have to apply, the way we have been applying, the way we have been converting one system of units into another, that was very easy because that was just conversion of SI into CGS, means the standard unit into the centimeter gram system. So with the help of that method, those questions you'll be able to solve as it is. Now it is saying convert power of 60 joules per minute into something you have to convert. But here the mass is different, length is different, and time is different. Means see, power, this is power which is given as 60 joules per minute. 60 joules per minute means 60 joules per minute means by 1 minute. It means 60 joules by 60 seconds. So it is ultimately 1 joule per second. Because minutes is not in our SI system. I have told you for time, you have seconds as the standard system. You have to convert everything into in terms of seconds. So 1 joule per second we have as the power. Now see again, N1 U1 is equal to N2 U2. You have to apply. So what is N1 given? You have N1 given as 1 joules per second. Let's go by this only. Because if we write 60 joules per minute, you ultimately have to convert 60 joules per minute also. Now you have 1 joules per second. So N1 is 1. What about U1? Unit 1 is joules per second. It's not this time just energy, joule. We have joules per second. What about N2? N2 we have to convert. And what is U2? U2 is the new unit where this is given in gram, length, and millimeter. This is the new system of units. Now, in our previous system, that is when we have to write for M1, L1, T1, what do we have? For us, mass is 1 kg. For us, length is 1 meter. For us, time is 1 seconds, right? So if I want to write this side, that is from the older system, joules per second, joules, second, these were from your earlier system, SI system, where SI's unit of mass is kg, the SI unit of length is meters, time is seconds, right? In the new system, we have M2, sorry, L2 and T2. So now this time M2, instead of 1 gram, it is 100 gram. Instead of 1 centimeter, what is the length given? 10 millimeters. Instead of 1 second, we have the time as 1 minute. So this is what is the difference. Otherwise, in our CGS system, we used to write this as 1 gram. We used to write this as 1 centimeter, and we used to write this as 1 seconds. All right. Now we have 100 gram, 10 millimeter, 1 minute. This is provided by the question. So it means now when we will be converting 1 kg, we'll convert it into grams, 1000 grams, the way we have been. 1 meter, instead of converting it into centimeter, we'll be converting it into millimeters. Instead of converting time into 1 second, the way we used to convert, we'll be converting it into 1 minute. Basically, we'll convert our older system in terms of the units that are given in new system, because we ultimately have to cancel. We have to find out N2, and N2 is just a number. When the units will be cancelled, then only we'll get a proper value. So what is joules per seconds? Firstly, now when we are talking about joules per second, that is power. Power's dimensional formula also we have done. See, m L square will be there. It's just that one more second is there. So t to the power minus 3 will be there. So this is the older system. That is in terms of this. N2 we do not know. New system we have m L t to the power, this is 2. So this is N2 again we have to find out. So what N2 will be? M1 by M2 to the power 1. L1 by L2 to the power 2, T1 by T2 to the power minus 3. All right. This is what is given. N1, N2, this is what is given. Now, we used to write before this question, when the system of units was not given, nothing was mentioned. How did we write? We used to write this as 1 kg by 1 gram. But this time we'll be writing it as 100 gram. Because this is a different new XYZ system that the question has just given us, so that we can solve it. So to the power 1. Then again, this we used to write as 1 meters. So again, I'll write it as 1 meter right now, then we'll convert. And this is given as 10 millimeters. And then we have time as 1 seconds by 1 minute. It is given as 1 minute. So this time our time will also not be cancelled. We will be having the time left also. See, one thing I'll tell you, 1 meter is equal to 10 to the power 3 millimeters. All right, because one more 10 gets multiplied. So 1 meter will be 10 to the power 3 mm. All right, then that's why only when milli has to be replaced, we multiply it by 10 to the power minus 3. Now let us convert. Let's start with the conversion, because then all these will be cancelled. So how will convert kg? Kg is 1000 gram by 100 gram to the power 1. 1 meter, see, we'll be converting 1 meter, but here 2 also is there. So we have 1 meter by 10 millimeters, but we have the square also. So let us write it as 10 to the power 3 only for the time being. 1000 millimeter. Power we'll square it in the last. Otherwise, it will become very confusing whether we have used the power. So it's 1000 millimeters by 10 millimeters, right? 10 to the power 3, 1000 millimeters by 10 millimeters. All right. Then we have seconds into minutes. So instead of converting seconds into minutes, it's better if we convert minute into seconds, because we have to have the same group of units. Ultimately, you have to find out the same group of units, because they have to be cancelled, they have to be divided. So instead of converting 1 second, it's better if we write this as 60 seconds to the power minus 3. This is power 2. So what all things are getting cancelled? See, gram got cancelled. 2 zeros are cancelled. From here, millimeter cancelled. 1 0 cancelled here. So what do we have now? N2 is equal to, this is 10. See, this is 100, but 100 into 100, power is squared. So that becomes 10 to the power 4. And see, 60 is in the denominator. So when 60 will go up, the power will become positive. 60 is now up in the numerator. So power will be positive. So 60 into 60. So cube of 6 we'll write 216. And then the 3 zeros here into 10 to the power 5. This is it. So what will it become? 2.16 if we write. So 1, 2, 3 zeros will come here, right? So this becomes 8, correct? If we write this as, so 2.16 into 10 to the power 2.16 if we write, so 1, 2, 3, 4, 5, 10 to the power 10 it will become, right? 5 zeros here and 5 zeros, 10 to the power. So this is how we have solved. This is the most difficult question if it will come in your exam. So all the types of questions, see, the basic questions that come from the dimensional analysis, this portion is basically convert 1 Newton into 10 Newtons, 1000 Newton, like this. But this is a question extracted from a textbook. So, and from NCRT's back, you have this question. So this is not difficult. See, it's just that you have to remember that this time you have a new system of units. And you have to place this data instead of the original data which you used to put. All right. Then again, you have to bring the same units and cancel them so that ultimately you are left with the number. One last question is also there. I'll discuss that. But first, all of you write it down. Any doubts in this question, let me know. I'll explain them. Write it. Okay, this will be the last question from this portion, dimensional analysis. So all of you write it and at least try it by yourself first. Fundamental unit of force is 100 Newton, velocity is 10 meter per second, time is 10 seconds. Calculate fundamental units of length, mass, and time. At least try this question. Then I'll discuss it in 2 minutes. All those who will get their answers, write it in the chat column. Okay. Let us discuss this question also. This is the last question. So these were the different types of questions which were possible from your dimension analysis. Otherwise, you have very straightforward questions. You have to write down the dimensions, the formula will be given. Now see how to solve this type of question. This says that if fundamental unit of force is 100 Newton, velocity is 10 meter per second and time is seconds. All right, means what is force? You have to find out the fundamental units of length, mass and time. All right. So force is what? Force's formula is mLt to the power minus 2. Did you notice one thing? I had told you earlier only. Remember 5 formulas at least for velocity, for acceleration, for force, and for work done. Because length you already know. So these 4 to 5 formulas, if you remember, these will be very helpful when you are writing the dimensions. See, force, velocity, these every time we have to write. Different can be constructed, but these are often difficult to write again, because see, for force you will have to again write m into a, mass into acceleration. For acceleration again velocity by time, then for a velocity again distance by time, like this. So if you remember it in one go, it will be very helpful for you, because then you will only remember it, right? If you remember it for force, if you remember velocity, then these are such dimension formulas that are used everywhere. See, at least you can remember these and construct the newer derived. So that's why I'm again saying the initial table which is given in the notes, the initial table which we have discussed, at least remember that. And out of those also, some of them which I have told you. Fine. So yes, force is this. So force is given as 100 Newton. What is velocity? Lt to the power minus 1, distance by time. This is given as 10 meter per second. Then lastly, we have time. Time is just t to the power 1. We have this as how much? 10 seconds. Now see how to solve this. Now we have nothing. We do not have any information left with us. We just have the information that we have to find out the fundamental units of length, mass is time, but forces, velocity, and time is given. No conversion of unit is present so that we could convert only that. This is a different question. This is not from your conversion of units. This is not a question from your writing of formula. See, altogether, this is a new thing. Now, how will we get? Units are also, it is not saying calculate the units so that we could use N1, N2's concept, nothing. Then formula equation also is not asked, because force, velocity, time, these are not getting connected anywhere and there is no formula for them. And then just simply writing down of dimensions we have done. So how to calculate their fundamental units? One thing in this, whatever is the system given. One thing we know is, see, if I say these are 3 equations, 1, 2, 3. Just pay attention to this question. It's a little different question, and if just in case if it comes in your exam. See, these last 2 questions are the tough questions that can come in your exam. So if they are coming in the exam, you should be prepared for them. So 1, 2, and 3 equations we are having. Now look, if I have t to the power 1 as 10 seconds. So if I substitute times value here, if I substitute times value here, means if I put 3 in second, it means t is 10 seconds. L is given. What is t given? T is given as 10 seconds. So 10. But power is minus 1. T is equal to 10. C. T is equal to 10 seconds. So t to the power minus will be 10 to the power minus 1 seconds. This concept is clear. T is equal to 10 seconds. So t to the power minus 1 will be equal to t to the power minus 1 seconds. So this is what I have. L into t to the power minus 1. This is equal to 10 meter per second further. Correct. So what L will be equal to? See, this is, let's do one thing. L divided by 10 I can write so that this becomes positive. Now power is positive is equal to 10. So L is equal to 100 meters. So time is equal to 10 seconds. Length is equal to 100 meters. Now only one quantity is left, that is the mass. Time is 10 seconds. It was already given in the question. So time was not a difficult thing to calculate because it was already given. What about the length? Using this length into the time. Time is missing. Time, I have kept it from equation third. We have calculated the length. Now, if we have length, we have time. Can we calculate mass from the first equation? So basically from in this question, what have you learned? You just have to, whenever you have such type of question, no, just put on substitution method. Substitute one variable with another. Treat it like the algebraic equations. You are having x, y, and z. Y is equal to 10 seconds. X into y is 10. So what will be x? X will be 10 into 10. That is 100. Then you have m into l into, that is x, y, z is equal to 100. So you have x, you have y. Now you have to find out the third variable. So like this, you have to calculate. If you have the third variable, you have the second variable, two variables, like this you have to calculate. So mass into length is 100, time is 10 seconds, but here the power is -2. M L T to the power -2 is equal to 100. So M is missing. What will M be? See, let's bring this also in the denominator. Keep on making the powers positive. That eases our work. So this is 10 to the power -2. It will go in the denominator. It will become 10 to the power 2. That is 100 is equal to 100. This 100 cancelled. Mass is equal to 100 kg. So what all things we have? See, time is equal to 10 seconds. Length is equal to 100 meter and mass is equal to 100 kg. So this, see, this is the reverse of the previous question. In the previous question, you had the new system of units and you had to find out the N2's value. Here, this new system of units is missing. N2 and all you have. Here, this is missing. So in this, whatever is this new system, XYZ system, you have time as 10 seconds, length as 100 meters, and mass as 100 kg. First till here, is this clear to all of you? Jesslyn has also joined.
Yes,
I
ma'am.
think clear. Jobita, what about you, Zainab?
Yes, ma'am.
Clear? Shaima?
Yes, ma'am.
All right. So see, this completes with the dimensional analysis portion. Write it down. One thing I'll discuss with you. First, write it quickly. Done or not, class? Still writing. Others also, only Jabita has completed. Harshid has also. This text done. I'll get an idea. So see, what all we have discussed in dimensional analysis. I'll just brief you with what we have done. So I think almost everyone has written. See, dimensional analysis, we started with see, this is a very basic chapter. Very basic chapter. All of you should be able to score marks at least in this chapter. Now, from now onwards, after this, I'll be starting with your calculus, because those students who are having mathematics, they'll be dealing with calculus in detail. I think it's in 12th. So, but the students, no, it's in 11th. But students, the physics is for everyone, and everybody has to solve the questions which involve your concepts of maths other than your simple algebra. So for those portion, you all should be aware of what is calculus. So properly calculus includes your differentiation, integration that I'll be taking. That's why I'm saying keep your 2 hours for the class prepared. Like today, you'll be having the after class assessment. If you are having the after class assessment at 8 o'clock, 1.5 hours class will be there, and half an hour your assessment will be there. If suppose on that particular day your after class assessment is not there, so I'll be exceeding with the class. Alright, depending upon your syllabus, because your completion of syllabus is also a major task. So keep your 2 hours ready and see. In dimension analysis, it's a basic chapter. What we have discussed: dimensional formula, how to write the dimensional formula, whatever is the actual formula, just keep on substituting it in terms of MLT, mass, length, time. Temperature will also be used somewhere. Questions do not go till luminous intensity, mole concept, or even current for your class limit. Usually, these questions are not there for your exams. Here, when we'll be having the class exams and all, we'll be seeing, I think I've seen Jessica's, no, Jesslyn's papers also. So you all just appear for your test, whatever tests we'll be having, weekly tests. So basic questions will be there. In the weekly test, some questions will be little difficult because these are for your practice. Ultimately, you have to score your school main exams, right? Your school exams are very much important. Their marks will be counted, right? So appear for these exams proper practice papers, because these will give you thorough practice. That's why some questions will be a little difficult. In your after class assessment, we have a section of advanced questions also, right? So in under advanced questions, what happened? You have the tough questions which are present. So at least you are aware of what type of questions are coming. Anybody has any doubt in the after class assessment, you can brief. So writing of dimensional formula, very basics. Secondly, how to find out the formula, means checking the accuracy of formula. Whether one thing is proportional to another. So what are the powers that you have to check? Again, dimensional formula will be used. Lastly, conversion of one system of unit to another. Now see the first chapter, that is this physical world. This has one part dimensional analysis. Second part is error analysis. So error analysis class, this has been completely deleted from your syllabus, and it's a very lengthy topic. So it's not a very short topic that I'll discuss it in 5 minutes and I'll brief you. So this is in detail. Students who will be preparing for their entrances after class 12th or during class 12th, that time we'll study error analysis. But right now, this is not a part of your syllabus, so we'll not be doing it. The last part, the third part of this actual chapter is measurement of length, mass, and time. This is measurement of length, mass, and time. Now see, for measurement of length, mass, and time, this is a very, I have written it in very concise manner. Only the things that are important, not for your exam. See this part, measurement of length, mass, and time, this is not important for your exam. Very few questions come from this. Usually the questions are from your dimensional analysis, because that is much more important. I have written it briefly, very briefly, this portion, because why I want to discuss this with you. It will take 5 to 10 minutes only, because this will be used throughout your physics also. It is helpful for the rest of your physics also, like light year, astronomical units. These are the units that will be used. significant figures is also not there. Significance, earlier it was there, and I think it's in your chemistry, it's still there. Chemistry, I'm not sure, because if it's there in chemistry, you will be studying it in chemistry. From physics, error analysis, significant, actually your significant figures, no, it's a part of your error analysis only, because you round off the values and then you limit the errors. So that is not there. But I think you will be studying it in chemistry. That I'm not sure. That you have to confirm it with your chemistry teacher. So this portion, I'd suggest all of you to at least go through, because this is very concise manner. I have it. Otherwise, it was very much in detail. So let me tell you what all things we have. Light here will be asked to you in your gravitation chapter somewhere. You might be needing it. So that's why let us at least brief ourselves with this. So see what is meant by light here. Light here basically is the distance that, see, these are the distances, the large distances. Like if we have to take the distance between moon and earth, sun and the moon, like this. So these are for very large distances, basically the astronomical units that. So what is the distance covered by light in 1 year? Now see, what is the speed of light? Please remember this. This I'm telling you right now. This will be used throughout. It's a very, very basic thing that will not be available to you in the questions. Speed of light is 3 into 10 to the power 8 meter per second. Remember it like you remember the value of 1 kg is equal to 1000 gram. Like this. It's such basic. So 3 into 10 to the power 8 meter per second. So what does this mean? This means that in 1 second, the speed of light, that is in 1 second, the light is covering 3 into 10 to the power 8 meters. Right? So if this is the time, see, in this time, it is covering this much of distance. Distance, time, velocity, all these things we'll study. So in 1 second, if it is covering this much distance, what is light year? The distance traveled by the light in 1 year. All right. So in 1 second, it is covering this much distance. So if we multiply it with the entire year, we'll get it for the year, right? So that calculation part you do not have to do, but I'll tell you, see, for one light year, when we are taking, this is 3 into 10 to the power 8, 1 second for just seconds. So how many days? 365 days. Days we have taken, now we'll take hours. How many hours are there? For 24 hours in 1 day. Then we'll take in 1 hour, how many minutes are there? 60 minutes are there. In 1 minute, how many seconds are there? Finally, there are 60 seconds. So this is the entire calculation. Because distance is equal to speed into time. This is a formula that you have to remember later on. Right now, do not focus on the formula. So this entire calculation, 1 light year, when we write, this is 9. Remember this value as it is, 9.467. See, in this, no, do not round it off. All right. Let me complete it. 10 to the power 15 meters. This is value of 1 light year. So if anywhere you see light year mentioned, just multiply it with this, you can get your answer in exact meters. That is your 1 unit, which is light years. This is enough. Second thing which you have to remember is astronomical unit. Astronomical unit means this is the earth, this is the sun. Now the separation between the center of earth and the center of sun, this is called as 1 AU. That means astronomical unit. Separation between the centers of earth and the sun. So it's the average distance between the center of the sun and the earth. Again, this value, you do not have to perform any calculations. Just remember it as it is. So 1 AU. This is 1.496 into 10 to the power 11 meters. So these two values are enough for your class 11, astronomical unit and light years, only these are. One easy question is available. Let us just solve it. See, what is the ratio of 1 light year and 1 astronomical unit? This is a very common question that I have seen in your exams coming. If any topic or any question is there from your this measurement of length, mass, and time. So this value I remember. So you all can also remember it because I'll also not be performing this calculation. It's very difficult to perform this calculation during your exam time. So the third quantity that you have to remember is their ratio. Remember what is 1 light year? Remember what is 1 astronomical unit? Just by looking at this question during your revision, when you are having your exams during your revision, just look at this. This will give your entire, all the three values. By looking at this, you can see this is your light year. By looking at this, you have the value of astronomical unit. So how much 1 light year is equal to value of 1 AU? Means how much the ratio. So 1 light year by 1 AU, when you take, this is 9.467 into 10 to the power 15 divided by 1.496 into 10 to the power 11. Meters by meters, so meters will be cancelled. 1 light year when you are writing, this is 6.353 into, this becomes 10 to the power 4 AU. So 1 light year is equal to this much times the value of astronomical. So during your revision, when you have completed the entire portion, when you are just revising, just look at this question. That is enough. It will take 2 minutes. Just look at the value of this for light year. Just look at the value for mass and time. This is sufficient. Write it down. All right, class. So this completes with the first chapter. Second, see, before starting with motion in a straight line, class. Motion in a straight line is a part of your kinematics. So you have all the concepts of distance, displacement, speed, velocity, acceleration. Then you have uniformly accelerated equations, motion under gravity, relative velocity, and all. But before that, this is a topic of your maths, which will be applied in the physics. Understood? This is actually, this calculus portion has two topics in it. One is differentiation and other topic is integration. So some topics are present, some questions are present, and some physical quantities are present in your from your class 11th onwards that are not limited to just your algebra. Means all the operations, plus, minus, your division, your multiplication, all these four will not be applicable. You will need a new system to solve your answer. You will not be adding, you will not be multiplying, you will not be dividing, you will not be subtracting. Harshid, I have shared these notes with you, both the IDs. One ID bin, some name was given, and other one was your name, Harshid, Sayyid Harshid Ali. Both of these I have shared with you. See, I have shared with all of you, all those who have given. I think only Jesleen has not given the ID to Learnivio team. Otherwise, I have shared the rest of the portion also. See, sharing part. See, this is no benchmark. This is the email. Then this is your Hashid Ali. I'll check again. Okay, yes, check again, Hashid, and confirm. Because Zainab has also received it. So we were on motion in a straight line. So these two topics, these will be needed. So I'll be starting first with differentiation only. Then I'll go to integration. So these are like the topics, the way algebra is necessary. If I say 3x plus 2x is equal to 5x, you add it. So other operations to solve some quantities which is very, very, very small. These are so small that they cannot be added. If you add them, you will always get your answer as 0. If you will subtract them, you will also always get your answer 0. So I think not enough time is left that I'll start with differentiation. Now I'll start it in the next class only. So I'm just telling you the plan. First we'll do tomorrow. We'll start with differentiation. Why do we use differentiation? Why do we use integration? What are the differences between? Then once calculus is done, then only I'll start with motion in a straight line. Because many students who do not have maths, or if in your mathematics this portion is not covered, this is necessary. Everybody has to do this because this is the basics of physics. Without this much mathematics is necessary, at least your 10th class maths plus these two extra things. All right, class, you can appear for your after class assessment today. I'll not be starting with a new topic. I'll start it tomorrow then. All right. Thank you so
Okay,
much,
ma'am.
class.
Thank you.
Bye, ma'am. Thank you.